I know these are kind of tough, and you'll probably use a little bit of extra time to finish them up, but let's take a look at them, see how you're doing on them so far. See if you're heading in the right direction at least. So for the first one over here, finding the area and the perimeter. Let's do the area first. So for the area, the first thing you got to do is find the area of the whole circle, which is going to be pi times 4 squared. 50.24 inches squared. So then the area of that sector is the 50.24 times 100 over 360, because that's the fraction of the whole circle that it is. So 13.96 inches squared is what that ends up being. So that's its area. For its perimeter, we'll find the length of this arc out here first. So the length of that arc, we start out with the circumference of the circle. Which is pi times 8, or 25.12. And then we use that to find the arc length. 25.12 times the 100 over 360, which is what, 6.98 inches? Is that right? Okay, so that's the arc length, but we're asked to find the perimeter of the whole thing. So we've got 4 inches here and 4 inches there that we have to add on to it. Plus 4 and plus 4, 14.98 inches. Anybody have that whole thing right? Both area and perimeter? Any questions on it? Okay. The second one is the tough one. Because if the first one wasn't bad enough, right? And the second one, to find the area of that red space, first thing we have to do is find the area of the whole sector. Now, I made this one pretty simple to find that area. We're going to find the area of the whole circle. Pi times 10 squared, which will be 314 square feet. The area of that sector well, since it was 90 degrees, I could have just done divided by 4. But we'll do times 90 over 360. Which gives us 78.5. Come on. No, it's not. The batteries, I think it's going to be replace the battery every 3 or 4 weeks is what's going to be in this thing. Yep. Quadruple A, so it's not an easy one to find either. You have to order them. So the area of the triangle is 10 feet by 10 feet divided by 2, which will be 50 square feet. So then the area of that segment, which is going to be the difference of those two. So that's 28.5 square feet is the area of the segment. The perimeter of the segment is a little bit tougher to find. We're going to find the circumference of the whole circle, which is going to be pi times 20, which is 62.8 feet. This is 90 degrees, so we're going to do that. For the arc length on the outside, 62.8 times 90 over 360. Again, we could have just divided by 4. So 15.7 feet. So what we have there is this arc length here is 15.7 feet. We need to find the length across here. To do that, that's a right triangle. A squared plus b squared equals c squared. 10 squared plus 10 squared equals c squared. Well, 100 plus 100 is 200. Square root of 200 is 14.14. So we take that arc length of 15.7, we add 14.14 to it, we get 29.84 feet is the perimeter of that piece. That was a pretty ugly problem. I'm going to actually redraw that one down here for a second. This is not something we went over yesterday, even though it's going to look a whole lot like it. It's kind of backwards from something we did yesterday. I want to find the distance from that chord out to the furthest point on the arc. So that distance right there. Now, from what we learned yesterday, we know that if that goes out, if that comes off here at a right angle right here, that it has to cut that chord in half. So this is going to be 7.07 and 7.07. Look familiar so far? We know that from the center of the circle all the way out is how far? 10, right? So if we could find this distance, of course that has to be a right angle, we could just subtract it from 10 to get x. Well, we can find that distance right here. This is 10 and that's 7.07. So I'm going to go A, B. The 10 is now C because here's the right angle. So A squared is equal to C squared, 10 squared minus B squared. If you calculate that all out, you're going to get that A is 7.07 feet. That was a 45-degree angle. Because that's a 45-degree angle, that's a 90-degree angle, this has to be a 45-degree angle. So the two pieces, the two legs have to be the same. Because this was a right angle here, and those two radii really have to be the same, that means these two are 45-degree angles. So that's the only reason why it works out that way. Those are the same. But if that is 7.07, this up here has to be 10 minus 7.07, or 2.93 feet. Which actually, a little bit easier than some of the stuff we went over yesterday. So now, our next step if I tell you that this across here is 36 inches. And this here is 6 inches. Find for me the radius of that circle. I'll give you guys a couple minutes to give it a shot. So we can divide this into two pieces. We're assuming that hits at a right angle, so that has to cut this in half. So that we can draw in the rest of the diameter here. We're going to label that X. So the first piece we're going to find here is X. And X is found by multiplying together these two pieces of the main chord there. 18 times 18. And then dividing by this little piece, the 6. That's going to give us X. Well, 18 times 18 divided by 6 is 54. So X here is 54 inches. With that, then we can find the diameter, which is 6 plus 54. So 60 inches. So the radius, of course, is half that. 30 inches. What do you think? Better than a sharp stick in the eye? It can be. Yeah, we're not going to do that to you yet. That's in the spring. Oh, trying to make this one work out. I don't think I can. Oh well. Let's say this distance across here is, we're going to call it 64 inches. And this here is 8 inches. Find the radius of that circle for me. So how do we find X? (32 times 32 divided by 8. Perfect. So that is 128 for X. From here to here. Of course, the 32 is just from half of the 64, right? So then our diameter, you got it. 8 times 21, or 8 plus 128 is 136. And the radius, 68 inches. Perfect. Okay, well, our new stuff for today, I'm actually going to take it a little bit easy on you today. It's in the packet I already gave you on the last couple of pages. They talk about octagons. And we're going to talk about regular octagons. What's that? Oh, what movie is that? The Octagon? Oh. No, I don't think I've never even heard of that one. Okay. That's okay. It's better than the joke one of my students piped off. Does that mean it gets enough fiber in its diet? Yeah. It's nice to know I'm not the corniest one in the room, right? Not all the time. That's as close to a regular octagon as I am capable of drawing. A regular octagon means all the sides are the same length, all the angles are the same. That little hash to the side means all the sides are the same. So I'm going to label a few things. S is the length of a side. F is a flat distance from one side to the opposite side. D is the diagonal distance from one corner to the opposite corner. So obviously here D is going to be longer than F, and S is shorter than either one of them. If I happen to know D, the area of the octagon is 0.7071 times D squared. Now this all comes from trig. 0.7071 is actually the square root of 1/2. But let's say I've got an octagon here. And I'm trying to fit the octagon inside of a circle. For example, let's say that I have a shaft that's 2 inches in diameter. And I'm going to machine the end of that shaft down into an octagon. The largest octagon I can get off of it. Yeah, so I'm just going to put those 8 flat surfaces on it all the way around it. What's the area going to be of that shaft? Well, that area is going to be 0.7071 times 2 squared. Yes, times 4. So that's going to end up being 2.828 inches squared. It'll be the area of that shaft. Does that make sense? What's that? Math is pure logic. Come on now. If I know the flat distance, the area is 0.8284 times that flat distance squared. Now again, that 0.8284 comes from trigonometry. So I'm not going to show you where it comes from. Not yet, at least. Now you're catching on. So let's say I'm going to machine that octagon piece, and I need to machine it in such a way that I can get on it and turn it with a 1/2 inch wrench. What's the area of that octagon going to be? Well, that means the flat equals 0.5. So the area, come on now. There we go. So the area of it is going to be no, that was my screw up. 0.8284 times the 1/2 squared. So 1/2 squared is 0.25. So that's 0.2071 square inches would be the area of that octagon. Then the final little formula, if I know the side length, the area of the octagon is 4.8275 times the length of the side squared. So if I need an octagon, let's say that we need this to be 12 millimeters on the side. The area of that's going to be 4.8275 times 12 squared. is 695.16 millimeters squared. Now, the neat thing about these little formulas is I can work both ways with them. Let's say we want this octagon piece here again machined. Pretend that looks like a wrench. It kind of does. Machined again so that I can fit a 1 1/4 inch wrench on it. And I want to know what the length of each side of that octagon would be then. To find that, I can use that 1 1/4 to find the area. What dimension is that? The side, the flat, or the diagonal? The flat. So the area is 0.8284 times that 1 1/4, I'm going to write it as 1.25 squared. $1.2944, we're going to call it. No, that's the area. If the flat is 1 1/4 inches, the area of this whole thing is that. Now we're going to work backwards to find out what the side is. The area is 4.8275 times the length of the side squared. But if I happen to know that that is equal to 1.2944 square inches, I'm going to work backwards. So I'm going to divide by the 4.8275. So I'm going to take this answer, I'm going to divide by 4.8275. And then what? To get rid of s squared, I got to square root that result, right? So 0.2861. I've got to square root that. 0.5178. So the length of that side is 0.5178 inches. And I can use those formulas. If I know any one of those 3 dimensions, I can find the area and then work backwards to find the other one of those other 3 dimensions. In your packet, on page 170, there are problems on these octagons. The formulas that I just gave you, by the way, are on the previous page, or previous pages possibly. Yeah, 168, 169. Actually, probably just 169 and the top of 170. And of course, I'm guessing some of you didn't get finished with 165 through 168. So finish those up as well.